I say, once a Burke Fellow, always a Burke Fellow. We now have a strong group of fellows, and their growing network is a great asset to Caltech. Theoretical physics is one of Caltech's traditional strengths, and the Burke Institute has made it stronger. Physics research is not just about solving equations. We spend a lot of time crafting the right questions, solve them, and gain new insight into our universe.
The investment in the future is really the essence of what the Burke Institute is about. It favors dynamic young people who are the future of the field. It favors individuals who talk across subfields.
Burke Institute allows us to study all these interesting topics that we wouldn't otherwise be able to work on. What's special about the Burke Institute is that it invests in people. If you invest in people and let them discover those most exciting things to work on, you can really make scientific progress.
What I've been thinking about over the last few years has been really the question of dark matter.
A lot of my work is trying to find algorithms that are useful for quantum computers to solve really tough problems that classical computers can't solve.
My research interests largely involve gravity, quantum, and classical.
When I'm talking to prospective postdocs who are thinking about coming to the Burke Institute, I always tell them that they're going to have more opportunities here than anywhere else I can think of, that I think is pretty hard to find anywhere else.
I remember having conversations with my advisor, and he said the Burke Institute would be the right place for you because it's a high risk, high reward. You're going to have a lot more independence.
It was kind of like being in like a sci-fi warp drive where I was a student and then I was thrust into the frontier of cutting edge science, and it was intense and incredible.
Just the fact that it's a 2-minute walk to astrophysicist's office, 2-minute walk to people working in particle physics, more ideas spawn from that.
I remember when I walked in out of the elevator for the first time and seeing all these Feynman diagrams on the wall, I just thought that this place is absolutely incredible.
I had it mistaken as a student. I had thought that one just pushes really hard and writes lots of papers, but what I'd realized from working with these people day in and day out and seeing them is that they've achieved the success because they actually had fallen in love with the work.
Burke Institute is really the intellectual home for me. It's exciting to be at the Burke Institute really because of the people around. Everybody is expert in their own field. Everybody has a story to tell. I would usually call myself a condensed matter theorist, meaning that I study many-body quantum systems, but my research really spans many different areas of theoretical physics.
I am a high-energy theorist, but I have worked with Burke Fellows in quantum information and in condensed matter physics. Working with people from different areas is stimulating and leads to new discoveries.
I realized that what I'm doing has a lot of connection to field theory, to high energy physics, and maybe eventually will take me to gravity. Who knows?
A lot of the most pressing questions in modern physics are being tackled at the Burke Institute. I really would like to discover dark matter, but that would be pretty awesome, or at least get close. It's at the intersection of theoretical particle physics and theoretical astrophysics, and trying to really understand, based on the motion of stars in the Milky Way, how much of dark matter there is in our galaxy.
The thing that's most exciting to me is all the little questions. It's figuring out how everything fits together. So for instance, merging black holes are a really exciting field in astrophysics, but I want to understand, how did that happen in the first place?
One set of interesting problems that I've been looking into recently that quantum computers can solve are chemistry-related problems. Properties of these kinds of physical systems that quantum computers, it seems like, have a serious advantage over traditional computers.
Being a gravitational physicist in 2024 is extremely exciting. There's so much to think about right now. Back in the day, you have Kip Thorne as one of the only people seriously entertaining gravitational waves. And you fast forward till now, I'm learning about gravitational waves and I'm working out these problems that were once very complicated, but now we have all of the tools.
I'm very excited about the Ginsberg Center and the Kip Thorne Laboratory, funded by the Sherman Fairchild Foundation, being constructed next door to this building. Effectively, we'll expand the size of theory group floor And there will be more interactions between us high-energy theorists and quantum information theorists.
That building will also bring precision measurement experiments together with theory group, and that's another crucial connection in the quantum field, because the close connection and mutual inspiration between experiment and theory is the fundamental force driving physics forward.
What we have accomplished over the last decade has exceeded my expectations. Our achievements have been recognized by Nobel Prize, Breakthrough Prize, Simon's Investigators Award, and many other prestigious awards. Just 1 year after the Burke Institute was founded, the LIGO Observatory made the first direct detection of gravitational waves. The identification was only possible because of theoretical research in numerical general relativity led by Kip Thorne. The name Burke is now very well recognized in science.
To have such steady, strong support of theoretical physics is crucial. Well, not just to my research, but to the world.
The Walter Burke Institute is a recipe for success. It is a recipe for continuing discovery over many years to come.